A warm welcome to the Evolution Show. I'm Johan Landgren. I hope you're great. If you're new to the channel, Evolution Show is all about finding solutions for a renewable energy future and meeting the biggest challenges of our time, including artificial intelligence. And today I'm joined by the CEO and founder of a company that may become a game changer for the energy sector. I'm joined by Joakim Byström at Absolicon, a company that has developed what may be the most energy efficient way to generate heat in the world, using only solar thermal collectors. The technology is already used in large communities and later this year in a large city in a cold climate, planning to go 100% fossil free thanks to this technology. You definitely don't want to miss this episode. And if you like it, don't forget, give it a thumbs up and consider subscribing to support the show. Let me know what you think in the comment section below. Okay, let's get going. This is the Evolution Show. Welcome back to the Evolution Show, Joakim Byström.
Tack så mycket. Thank you.
Yeah, you are the CEO and the founder of the Swedish company Absolicon. Yes, and you were on the show, I think, a couple of years ago. The second time. This is the third time, I think. You have developed the most efficient solar thermal heater in the world.
Yes.
Yes, and so, I mean, we can just start with that. Can you tell us about your company? And of course, then we can move on to look into this fantastic technology.
Yeah, we come back to this with the most efficient.
Yeah.
But Absolicon, we are a Swedish technology company being working with solar thermal for 20 years. And we have developed a unique technology to focus the light and produce heat and steam. Not for small houses, but for industries and district heating. And we have not only developed the solar collector, but we also developed a way to mass produce the solar collectors in a robotized production line. So that is our key competence.
Yeah, and you have developed a solar thermal system that is for commercial use. And I know that the efficiency rate of these solar thermal heaters are extremely high. Can you tell us a little bit about that?
Yes, we have achieved the 76.4% optical efficiency, and that is the highest ever measured for a small parabolic trough. And solar thermal in general has much higher efficiency than photovoltaics that make electricity. A typical photovoltaic panel have 18 or 20% efficiency. So if you put 1000 watts of solar radiation, you get 200 watts of electricity out of it. That you have 20% efficiency. But we have 76.4%, and that is the amount of the direct sunlight that is converted to heat. And I should mention that this is for this specific type of parabolic trough that we are working with. There are other types of solar thermal collectors that are operating at lower temperatures that might have as high or higher efficiency. But when it comes to making heat and steam with a small parabolic trough, then we have the highest efficiency.
But clearly, I mean, the efficiency is 3 or 4 times higher than photovoltaics. So it's
yeah.
And I know that one of your key messages that you often talk about is that half of the energy we use globally is in fact heat. So
yeah, this is something often forgotten. People think that the world is run on electricity because electricity is what we see around us and that we have in our daily life. But if we look at the final consumption of energy, it's only 20% that is electricity for lighting and computers and motors. 30% is for our transports with buses and cars and boats and airplanes. But 50% is burning fuel to get heat. And this might be heat to heat a house or a commercial building, but it's also heat to run industrial processes. So if you have a dairy, for example, you need to pasteurize the milk, and you never do that with electricity. You always burn fossil fuel to get steam, and you use this steam to pasteurize the milk. So all the industrial processes we have around us to produce our clothes, our food, our medicine, they are run by a big steam boiler in the back of the factory, burning fossil fuel and running the factory. And this is forgotten because when we come into the shop, we see the lights in the roof and we see, oh, this shop is consuming electricity. But you don't see all the carbon that went into making the clothes that are actually sold in the shop.
No. And I think it's easy for people to kind of misunderstand or dismiss solar altogether because they see the photovoltaics and they see that, oh yeah, it's a couple of % of the whole energy use in a country or even globally. But what you're looking at is at least 3 or 4 times that, and on a global scale you can actually increase it even further since it's heat you're talking about, right?
Yeah.
Yeah.
The International Energy Agency, they say that by 2050, 11% of all this heat that is consumed in industry should come from solar thermal. So there's a big transition here where industry traditionally burn different fuels to get heat, but in the future they will use solar heat directly from the sun.
And I think we can just head into the really interesting discussion, I think, straight away. I mean, when people watch this, they might wonder, oh, okay, yeah, they're talking about solar heat, but how about winter? I mean, you can't store it. Like with all solar, you can store in batteries, yeah, but for a few days or hours or you know, and so on. And it's an intermittent energy source. And so, but you have talked about it several times that there are several really interesting projects to cover this.
Yes. So solar electricity is very difficult to store from summer to winter, but solar heat is easy to store. And there are a number of technologies with boreholes and different kind of salts and other methods to store it. But the cheapest is to use a pit storage, which is basically a big hole dug in the ground, and then you have a liner inside to make it watertight, and then you fill it up with 95-degree hot water in summer, and then you have hot water all winter. And this is a technology that fits well for small cities. So the city of Dronninglund in Denmark, for example, they have this 30,000 cubic meter of heat storage. And as it's so big, the heat losses are very small because the edge of the storage is small compared to the total volume that it's storing. So large thermal storage can store solar heat from summer to winter, both in cities and in industry.
And this is, I mean, this is up and running right now, and it's providing energy for thousands of households, I understand, if you look at the whole of Denmark in this case.
Yes, actually, in Denmark, there are 125 cities using solar thermal heat to heat the cities.
Yeah.
Something basically unknown in the world that Denmark had this development.
Yeah, fantastic. Okay, but right now, your business is actually making the production lines you have developed the product, obviously, but you're not selling it directly to the customer. So people might wonder, okay, I'm a business now watching from the US, for example, a medium-sized company. We have a lot of heat or we generate surplus heat. How can we get hold of this product?
Yes, in North America, we have a Canadian partner, Phoenix, that represent us and is underway to build a production line in Canada. So we have around the world different partners who can help with this kind of feasibility studies to study projects and make quotes for full-scale installations. And this is a development happening right now, I would say. The companies and cities has been quite happy as burning fossil fuel for decades and decades, but we are right now in a situation where many industries are thinking about how they must stop burning fossil fuel.
And it's very, people might wonder why you're not selling this directly if the product is so amazing. Why you're not selling it? But you have there is a reason behind that. Why you're making the production lines and focusing on that to scale up this to make it available to. I mean, obviously we need a lot of solar thermal to cover the needs, right?
Mm-hmm. Well. Yes, I would say that it's similar with the electric car industry, that when Tesla started, they could sell a very, very expensive car because it had extreme prestanda. But when it comes to energy, 1 kilowatt hour of heat from solar thermal is the same as 1 kilowatt hour of heat from fossil fuel. So you need really to outcompete fossil fuel on price. And you can't do that by producing small scale and selling collectors from Sweden. You need to get really local mass production in a robotized production line. Then you can outcompete fossil fuel. So there is no small scale start of outcompeting fossil fuel because you can't get down in price. You need to find a pipeline of industries that want to change their energy usage, and then you build a local production line where the robots make solar collectors and they will get cheaper than fossil fuel. If there were an industry out there who happily would pay 3-4 times the energy cost, we are of course happy to ship collectors from Sweden. But what we see is that that appetite is very limited. People want to have lower energy costs when they decarbonize, not higher.
And when you see 3 to 4 times more expensive, it's basically the upfront cost that you're talking about. I mean, in the long term, if I will invest in a commercial system like yours, I guess if it, let's say it could last for 40 years basically, or even more, but over that time, I probably would make a profit, I guess.
Yes, but even if you take into account the payback time, if you want a small installation in a country far away, it will be expensive.
Okay.
What you need to do is to build a large solar field and have a local production. Then you can undercut the price of the fossil fuel.
Yeah.
And we have tried this business concept, selling solar thermal fields that had like 20 or 25 years payback time, but no one wants to buy them, even if they get energy that is without CO2 emissions and very little short energy payback time. People want to have cheaper energy. They want to have fossil-free, cheaper energy.
Yeah.
And that you can only get by accumulating a pipeline of industries that want to change and then establish a local robotized production line.
Yeah. Okay, but so far you have sold 2 production lines. You mentioned one in Canada and one in Egypt.
Yes, exactly.
Can you tell us about these projects?
Yeah, both those countries have entrepreneurs who started this work together with us. And the first step is to build this pipeline of industries that want to have the solar collectors. And here we work with the big multinational companies. Absolicon have agreements with 7 out of the 20 largest multinational food and beverage industries that has committed to reach 0 CO2 emissions. And we work with their local factories then making feasibility studies and making quotes and offers and building this pipeline that will fill up the production line. So in both Canada and Egypt, we have started to do those work to install the production line, but the production line will not be up and running until we have sold those big solar thermal fields, because they are the key to establishing the local production. So it's a little the egg and the hen problem that you need to have the customer for the solar collectors large scale to have the production line, and you need to have the production line to get the solar collector sales. But I think we have found a good middle way here. We have the production line here in Sweden. People come and look at it. We are selling pilot installations of the solar collectors that we have now with Carlsberg in Greece and with Peroni in Italy, where people can go and have a look and see the technology working. We also have here very nice, the installation you see behind me actually with district heating, where we can demonstrate that even in the north of Sweden, we can produce 110-degree hot water for the district heating system. So we're making those pilots around the world, and then we are taking orders for the large fields.
So the pilot then in Canada, if I understand you correctly, do you have an idea when it will be ready, or is that reliant on having more customers based in North America, for example, or are they building this line as we talk right now?
Yes, they have done the first down payment on the production line, but we have 4 large industries now that we are doing feasibility studies with, and who have applied for money in those quite generous support systems that are now in North America. So we are just waiting for some of them to mature, and then we will start delivering the collectors in North America. In North America, we actually haven't built any small pilot, so we are using the European pilots to show to customers.
But if you then move on to the kind of industries that are very, interested or should be interested in this kind of technology, it's food and beverage companies are in that sector for sure. And so can you tell us about, you mentioned Carlsberg, can you talk about that project and perhaps some others?
Mm-hmm. Yes, when you brew beer, you burn about 2 liters of oil to make 100 liters of beer, because making beer is a heat process. You need to boil the wort, and then you have the bottles need to be washed, and then you need to pasteurize the bottle filled with beer before you send it to the customer, so it won't continue to brew in the bottle. And then every 6 hours you need to run hot water in all your pipes to clean them. So a typical brewery like the one in Carlsberg, it runs on natural gas, and they have committed to have 0 CO2 emissions by 2030. So we have built a small solar field there that provides steam to their pasteurizer, 160-degree hot steam to the pasteurizer. So this is quite typical what we see how it will work in industries around the world. And this specific installation does not have any heat storage, so we operate it when there is sun. But actually, just without the heat storage, you can do a lot of good in the energy system. And one of our saying is that stop burning in summer. So I think that's a good first step. Of course, it's nice to have solar heat in winter, but the first step is to have solar heat in summer. So Carlsberg is a good demonstration on this, that instead of burning fossil fuel, you can run your factory on solar turbines.
And another customer or pilot, you might say, is Colgate.
Yes.
Can you tell us about that project?
Yes. Basically, all industries have large heat need. And the food and beverage are, thanks to that they are so sensitive to their customers' perception of CO2 emissions, they are the front runner, actually. But Colgate Palmolive, that makes household chemicals, is also a very large potential sector. I think if I remember correctly, Colgate have 62 factories around the world, everyone running fossil fuel, and they also have this commitment to reach 0 CO2. So on Colgate, we have built then a solar thermal field on top of their factory, a rooftop installation that provide pressurized hot water to replace burning of fuel, to heat up those liquids and perfumes that you need to mix before putting them on bottles and sending them out to customers.
And you have other projects as well. I know Tetra Pak is one of the more recent ones, right?
Yes, this is a very, very interesting concept. Tetra Pak actually runs 135,000 installations around the world in food and beverage plants. And the absolute majority of those are heated with fossil fuel. So when Tetra Pak is making their annual report, they need to declare their Scope 3 emissions, those enormous amount of CO2 emissions from all those pasteurizers and packaging machines they are running. And also Tetra Pak has a mission to reach 0 CO2. But then they need to help all their buyers of their equipment to get to 0 CO2. So what we have done with Tetra Pak is that we have made a specific module that is docked with one of their pasteurizers. So when they sell the pasteurizer, they can also sell this solar field that provides a large share of the heat need for the pasteurizer. So this is Tetra Pak's way to sell a green pasteurizing system. And what this is good for is also that often a big cost when selling a solar field is the integration in the industry, and every industry is different. But now when we have integrated with the pasteurizer, it's the same integration every time. We just sell a package of pasteurizer and solar thermal field, and all those costs with integration is just gone. And Tetra Pak is selling 3,500 new equipment every year. So having them to adopt this concept with green steam from a solar thermal field is very, very interesting.
How far are you in that process? Is this happening here in Sweden or somewhere else with Tetra Pak?
Yes, we have started to focus on Spain and Italy, and we have the first customer contacts. We hope to deliver the first combination to a customer in Spain within this year.
Oh, wow. Okay, but okay, let's say someone is watching this and think like, oh yeah, this looks fine and dandy, but how does it work in a cold climate?
Yeah, actually, the temperature outdoor is not the big challenge. We can produce heat in all weather. The challenge is how much direct sunlight you have. And like Spain and Italy has a lot of direct sunlight, but if you come to Thailand, for example, it's much less direct sunlight. They have much more clouds. So the temperature in the country is not a good indicator. Like Canada, that is quite cold, they have very clear weather. So you get a lot of solar thermal heat in Canada.
But how about snow, if I may ask?
Yeah, you know, the Absolicon collector, it tracks the sun during the day. So at night, it turns upside down. So the snow fall off. So snow is not actually a problem. It's the sunlight is the only parameter that you need to care about.
Fantastic. Yeah, I mean, if as a private customer, I would love to have one, but as I understand, this is something you are directing it towards commercial because of the price, right?
Yeah, I think for the price wise, the collector is not very expensive. The trick is that it runs with an industrial control system with the Siemens PLC.
Okay.
And it's not built for being run on a household. You need a professional service on it and this internet connection and monitoring of the temperatures that you produce.
So that's a perfect bridge to my next question then. How about maintenance? You're saying that this is something that you need, or how should you see it?
Yeah, we calculate 1% of OPEX. 1% of CapEx is OPEX. So the operating cost is very, very low for a big field. That's a few hours per month that you need to tend to the field and see that all the parameters are good, that the field is running fine. But that is basically the same if the field is big or the field is small. So this is also a strong push from our side to make bigger and bigger fields, because that also makes them a lot cheaper.
But let's say just if I'm just curious, let's say that we are 10 guys or girls or more in a small community and we see this technology. We want to invest in this as a private, community or foundation or what have you. Is that possible, or is it, excluded to commercial use?
No, I would say that if you had a small district heating network, that you have 10 houses and you have a joint small boiler where you maybe burn wood chip, and you feel it's very stupid to burn wood chip in summer when the sun is shining clearly, then you can have a small solar field from Absolicon and run the heat net in summer on solar and in winter on wood chip. That's a possibility. And we now have quite a number of that kind of inquiries, actually, not maybe from 10 households, but for smaller communities in Scandinavia that don't want to burn wood chip in summer, or like down in Europe, burn gas in summer to get heat when it's 25 degrees hot outside. It's quite stupid. So instead, you can just use solar thermal. And we are doing an increasing number of feasibility studies on this now.
And since we are here in Sweden, it's interesting to talk about this because about half of the heating from burning woods when it comes to heating buildings and waste products, and 90% of apartment buildings is heated this way. So wouldn't it be, I mean, I consider this a no-brainer. Why don't we have it here in Sweden?
Yeah. I think it starts with this idea that we can just burn the forest to get heat, that is a very convenient way. If we look 50 years back, we burned oil, and then we switched to burn tree and wood product instead. And I must say something, what we say that we use waste from the forest industry, because, for example, a popular fuel in Sweden are pellet, that is sawdust that is compacted. But before we burnt the sawdust in pellet, we used the sawdust to make spånskivor, to make compressed wood boards that you actually build the houses from. So this waste product was actually used to build houses. And nowadays we don't do that anymore. We just burn all the sawdust. So I think when we look at resource efficiency, this wood chip and this sawdust can be put to much better use than being burnt in summer in a district heating plant. And we actually have a study from the Swedish Energy Agency that says that it is profitable in Sweden to cut the burning of wood fuels by half in the year 2035. So solar thermal can actually reduce half of the burning of wood chip in Sweden. But there is such a strong feeling in Sweden that we are burning wood waste and it doesn't generate any CO2 emissions. So it's difficult to get people to understand this stop burning in summer because they are so happy burning wood chip and pellet in summer, even though with the recent price hike, it costs almost as much as oil to burn wood fuel now in Sweden. So I think there is a big need for the Swedish district heating and the European district heating industry to look into solar thermal.
Yeah, obviously. I think it's just a matter of logic. I mean, basically, it's if you could, and this is also a good bridge, I think, to another question I have is that you have made life cycle analysis, comparing, like, for example, coal and solar heat technology that you provide, and this is very interesting. Can you tell us about this?
Yeah, well, if you look at the CO2 emissions. If you burn oil or coal, you get about 400 grams of CO2 per kilowatt hour that you emit. And this need to go down drastically. If you look at photovoltaic panels, there is a common perception that a PV panel does not have any CO2 emissions, but actually producing one 235 watt PV panel, it burns 200 kilos of coal in China to produce this PV panel. But taken over the lifetime of the PV panel, you are still down at 40 grams per kilowatt hour on the PV panel. 40 grams of CO2 per kilowatt hour on the PV panel, which is much better than burning fossil fuel. But if you look at our collector that does not have this silicon and a very energy demanding process to make it, we just use some steel and some silver mirror and some glass. We are down at 8 grams per kilowatt hour. So we actually have 3 months energy payback time on our solar thermal system, which I think it's the lowest any technology has when it comes to energy payback time. PV panels and wind has between 2 and 4 years, and we have 3 months.
It's fantastic.
So, yeah, and this is important because if we're going to change the whole world's energy system, we don't want to destroy the climate and the environment by buying this equipment that is changing the energy system. We need to have systems that have very, very low environmental impact and very quick energy payback time if we are going to manage the energy transition.
Yeah, and we're going to come back to that in part 2 of our conversation, but just a little bit curious to talk about it here as well. The idea with the company is to produce many production lines, and that's because, as you just talked about, to scale up the availability of solar heaters in the world, because if we are going to replace even remotely a significant part of the fossil energy today, we need to scale up this really to a huge level from what it is today, right?
Yes, and that's not us saying that, it's the International Energy Agency and IRENA. And IRENA have in their plan that we in 2030 should have installed 1,260 million square meters of those concentrator systems in industry. And to do that, we require 500 robotized production lines running day and night. So this is also a reason why we have not focused in Absolicon to sell the solar collectors, but to sell the robotized production line, because someone need to focus on selling the production line. And there are a lot of solar thermal companies and other companies working on the local installation, but we are specialized in making those production lines. And we can quickly deliver those 500 production lines with help of our partners in Siemens and ABB. So what we need is those strong commitments from industries to actually do feasibility studies and start on this journey to stop burning fossil fuel. Because out of the 12,000 breweries, for example, that we see around the world, very few of them have actually started converting from burning fossil fuel to brew their beer. So it's a big work that hasn't started yet.
No. We're going to continue in the next conversation to talk more about, for example, how we can replace fossil fuels with solar technology, including the technology you provide with solar heaters. Because I know we had previously a guest that many people watched, and there was a lot of discussions after that. Arthur Berman, he's a geologist, and he said that yes, we should definitely focus on renewables. He's a petroleum geologist, an expert on oil and gas in the US, and he said that yes, we should do that, but it won't be enough. We need to even decrease our all total energy use, because when the production of fossil fuels decline, which he expects to happen in even a few years maybe, in that kind of decline rate, we can't replace it with the technology we have today, like solar and so on. The decline will go so fast. And you can discuss whether that will happen or not, but I think he has a really good point that we need maybe to decrease the energy use as well. And I'm going to come back to that and leave you with that question, but because in the part 2 we will talk about whether it's possible or not to do this transition, or if we have to go with what Arthur says, something else as well. I don't know if you want to comment on that already, but yeah.
I think the trick here is to get a good combination of different energy sources. But I would also say that building windmills or building new PV plants, it takes a lot of time. But solar thermal is really quick. We can ramp up very, very quickly. And we have given the European Commission, for example, plans how our industry can ramp up in a few years to provide a large part of the heat needed in Europe.
I think it's a really good point and a hopeful point to end on. I would also like to just finally ask you, where do you see Absolicon in, let's say, 5 years? If you were to, I mean, you can either answer that by saying as it develops right now, but if your dreams were to come true, how would that look in 5 years?
Now, we have quite concrete plans on delivering production lines to Spain and Italy and many other countries around the world. So I think that in 5 years we will have production lines in many, many countries, and we will have started this gigantic rollout of solar thermal technology to replace fossil fuel. And I think also in 5 years, the industry will be desperate to do this transition because they haven't started yet and it's getting late.
I couldn't agree more. And as Arthur would have said, Arthur Berman, that when time is running out, the fossil fuels production may start to decline in any year right now, and we need to start replacing it. It's not only for climate, it's just a matter of energy, if you want to look at that way. So we need to do this, and it sounds like your products, your solar heaters, it could roll out really fast. So that's hopeful. And
yeah, that is what Absolicon is built for.
Yeah. Fantastic. Thank you so much, Joakim. I hope people are inspired, and let's continue conversation in part 2.
Thank you. See you then.
That was all for today, folks. Tell me what you think about Absolicon solar thermal heaters. Do you agree, or do you see room for improvement? I hope you liked it, and if you did, don't forget, give it a thumbs up and consider subscribing to support the show. Next week, Joakim Byström is back to talk about how solar technologies like Absolicon's solar thermal heaters can have a global impact on our energy production in just a few years. You definitely don't want to miss that. I hope to see you next time.